Morning, everyone. I am Deepika, currently pursuing my sixth sem civil engineering in Sri Krishna College of Engineering. So let us discuss about concrete permeability. What is concrete permeability means? It is the ability to allow the water in the concrete and other fluids to pass through it. And this is the critical property to understand when designing concrete structures for durability. So next, what are the factors affecting concrete permeability means? One is water cement ratio. The higher the water cement ratio, the more porous the concrete becomes. And second one is aggregate type and size. Using aggregates that are well graded and have high density can improve impermeability. And curing process. Proper curing helps concrete to achieve its full strength and reduces permeability. And measuring concrete permeability are one is air permeability test, and it is used to measure the amount of air that can pass through a sample of concrete. And second one is water absorption test, and it determines the amount of water that is absorbed by a sample of concrete. And third one is a water permeability test, and it measures the rate at which the water flows through a sample of a concrete. Then importance of permeability in concrete are durability. Low permeability prevents water from penetrating the concrete, reducing the risk of damage from the freezing and thawing cycles. And another one is corrosion resistance. A low permeability prevents harmful substances like chloride ions from entering the concrete, reducing the risk of steel reinforcement corrosion. And chemical resistance, low permeability provides resistance to chemical attack, especially in aggressive environment. Another topic is sulfate attack on concrete. It is caused mainly by the chemical reaction, expansion and cracking, common sources and preventive. The first one is a chemical reaction. Sulfate ions react with the calcium hydroxide in a concrete, and these forms the expansive inner compounds. And second one is expansion and cracking. The expansion of these compounds creates internal stresses that can lead to cracking and deterioration. And common sources for sulfate attack is occur in environments where concrete is exposed to sulfate, rich soil, groundwater, or seawater. Preventive measures are using sulfate resistant cement and proper drainage can minimize the risk of sulfate attack. And causes of sulfate attack: sulfate rich environment. The concrete exposed to sulfate rich soils, groundwater, or seawater. Poor concrete mix design. In this insufficient sulfate resistant cement use of aggregates containing reactive sulfates, lack of proper curing. It is caused by the inadequate curing and poor drainage. Stagnant water allows sulfate ions to concentrate, accelerating attack. Effects of sulfate attack on concrete are cracking, and it is expansion caused by the reaction leads to cracking and spalling of the concrete surface. Another one is erosion. The expansive forces can cause the concrete to crumble and deteriorate, weakening the structure. The next topic is a chloride attack on the concrete. The components are corrosion of steel, rust expansion, structural deterioration, and potential failure. The chloride ions penetrate concrete and accelerate the corrosion of steel reinforcement. In the rust expansion, rusting steel expands, putting stress on the concrete and causes cracking and spalling. In the structural deterioration, corrosion and cracking compromise the structural integrity of the concrete. In the potential failure, the chloride attack can ultimately lead to premature failure of the concrete structure. Sources of chloride in concrete are one is seawater. It is present in the coastal environments and deicing salts. It is in the cold climates and construction materials, industrial waste, etc. The measures against the concrete attacks are use low permeability concrete. The concrete mix with the low cement ratio and use high quality aggregates. And second one is proper curing and sealing. Ensure proper curing to minimize permeability and seal exposed surface with appropriate coatings. And third one is utilize corrosion inhibitors. Incorporate corrosion inhibitors into the concrete mix to reduce the rate of steel corrosion. Design for drainage. Implement the proper drainage system to prevent the accumulation of the aggressive chemicals.
Next,